everyone. Welcome to the Ravit Show. We have a very special guest today. It's none other than Ashwin Rajeeva, co-founder and CTO at Accledata. Today, we will be discussing a lot around how Accledata uses Databricks Spark to automate petabyte-scale data validation and reliability. I'm super excited because Ashwin has agreed he'll be happy to go over and above and talk about the tech space, about startups, and any other questions that you guys have around data. Feel free to put in and don't forget to tag Ashwin, so he'll be happy to take those questions later in the chat. Also, a little about our guest. Ashwin is the CTO and co-founder at Accledata. He's a seasoned technology leader with 15 plus years of experience as a developer, consultant, and architect for data intensive software systems. Prior to founding Accledata, Ashwin was a software architect at Hortonworks, where he led the development of data plane hybrid cloud data services. It was here that he met Rohit Chaudhary, co-founder and CEO at Accledata, and both were inspired to start Accledata to address the problem of multi-million-dollar data initiatives failing due to lack of holistic view of data processing, data, and data pipelines across the enterprise. Also, we have a very cool giveaway that we are doing. Obviously, you guys know the ticker that's running below. What you need to do is just type in hashtag 365 data science, and I'll be picking up two winners from the chat. So feel free to type in hashtag 365 data science. All right, let's not make our guest wait anymore, and let's have Ashwin here. Hey Ashwin, welcome to the Ravit Show. How are you?
Hey, hi Ravit. How are you? I'm good, thank you. Thank you for having me.
Awesome. Ashwin, I was just letting folks know about a little about you, your background, how you met Rohit, and how you started Accledata. But we would definitely want to learn more about a lot around data observability space, about how you have seen things evolving. And I'm sure there'll be a lot of questions from the audience as well. Once we go, we'll be broadcasting this live. So definitely, I urge everyone, for those who will be attending this live, you can always tag Ashwin and add your questions in there. But to start with, Ashwin, can you introduce yourself?
Hey, yeah, thanks again for having me. So, yeah, about me, of course, I'm Ashwin. I've been in the data field, in and around technology for about, more than 15 years now. And, before Accledata, I was at Hortonworks. I was an architect there. I've lived, for about 5 years when I was at Hortonworks. I used to live in Berlin. I lived there for about 5 years, just to change of environment of sorts. And before Hortonworks, I was a consultant. So I worked with e-commerce companies. I worked with new banks. I worked with especially with things like even in e-commerce fulfillment. As a consultant, and before that, I tried my hand at a couple of other, being an early employee at a startup and starting my own kind of social media monitoring company with friends. And before that, I was at ThoughtWorks and so on and so forth, right? Most of my, work has been around, systems, and I consider myself as kind of an architect at heart, right? A software architect. So I would say most of what I do is figuring out how much can be done at what cost in what time, right? That's pretty much my skill set, and that is applying that to data systems, and more recently, with Accledata, trying to apply that knowledge to building observability for data scientists and data operators in general, and making sure that they have an easier experience at work, right? So data engineers, when they're working, they need the tools and the practices and the processes to kind of do their job better. So that's what we are doing in Accledata.
Okay, this is fantastic, and the way you describe what you do is so, actually it's very important that what you've mentioned. How much time it takes, what would be the cost, and obviously the cost cutting and all of those things as well, where you will be actually looking at the product very minutely. But definitely a great background that you've given. Thanks for that, Ashwin. Also, I know for a fact we'll be talking a lot around data observability, but just for our audience, how would you actually describe, like, what is data observability according to you?
Okay, it's a great question, and I think because the space is so new, and people are just starting to talk about it, right? So when we
Yep.
started out, let's say 2018 is when we started, and 2019 is when we said, hey, we are doing observability, but we are doing for data systems, so let this be called data observability. And we thought we were the first ones who kind of came up with this concept. But as it turns
Yeah.
out, of course, there are other people also working and thinking about this, right? Because in the industry, the common the set of problems that a lot of people face kind of have a tendency to baseline at some point in time.
Hmm.
And what we realized is that a lot of definitions are essentially floating around, but there's no one true definition, right? So what I'm going to do is I'm going to try to give you my best estimate of what we think as a company
Yeah.
data observability is, what our vision is, and how do you define it, right? So I will kind of put this very simply, and we will try to trace it back to the origins of the word observability itself, right? So
Nice.
observability itself is something newish. It's not been around for too long, but the idea is that, hey, instead of doing some sort of monitoring of your applications and apps and systems, which is more reactive in nature, you do a little bit proactive, instrumentation, and then you essentially, as a developer or as a function or as an engineering team, understand your applications and environments better, right? So that's observability, and then there's a definition for it which comes from control theory, right? Will not go there. But what it translates down in real life is that, hey, if you're an application developer and you're building an application, and let's say assume you write it in Golang or Java, you have to put in enough instrumentation and code and traces and logs to emit enough intelligence that you can then analyze performance at real time, which now is a standard practice. So if you're a professional developer, you need to understand frameworks like Prometheus, Grafana, Loki, Elastic, Log Search, CloudTrail, even going to companies which are Datalog and New Relic, right?
Hmm.
Now, there's a parallel trend. So, this is about observability and how it applies to application engineering. Now, there's a parallel trend which is happening, and this is, for everybody, is that in the last 10 years, data engineering and data science is essentially now a practice on its own, right? So, there was a
Right.
time where you didn't have a job called a data scientist, and now it's there, right? And it's like there are every company worth its salt has a data team, has a data engineering team, has a data science team, and is
True.
essentially looking how can they make intelligent decisions on the data that they collect, right? And this trend is essentially increasing, and you would see how value is being created in the data ecosystem by companies such as Confluent, Snowflake, Databricks, who have recently built mega companies on top of
Right.
the same motion, which says that data engineering is now as important as application engineering, right? And an
True.
important aspect of now that, since you're doing your data engineering as important to your enterprise as application engineering, it's also important that you maintain the same level of discipline or slash observability or understanding of how your data system is doing, right? And that tool set does not really exist. Why it doesn't exist? Because the concerns of the data team are different from the concerns of an application team. Most of application observability is all around latency. How long does something take, right? How
Hmm.
long did my page take to load? How long does my database connections doing? How is my heap memory? How is my CPU doing? How are my resource usages and wastages? Whereas on the data world, I think the parameters are slightly different, right? Where people are worried more about data reliability, they're worried about data quality, they're worried about data SLAs, they talk about data timeliness, freshness, volume, and all the other things which you talk about. When you talk about how do you monitor a data system, so they're fundamentally different, right? So for us,
Yeah.
this difference we could observe because at Hortonworks, which was one of the first companies to take advantage of the explosion in data engineering, data science. We see this day to
Right.
day, right? Where you have thousands of customers, and they have a similar complaint where they say, "Hey, I don't know how to monitor or how to look at my data systems." Where my concerns are not so much about CPU and perform, CPU memory and those aspects which you worry about, but more around, can this data be trusted? Can this data be relied upon? Does this data do my job? Why did this data not arrive today? Why do I have 10,000 rows out instead of 100,000 rows? Right. So we as a company, you know, what do we do? You got to imagine your entire, take a big enterprise. Let's take, um, Pepsi, right? And like any other enterprise, they are on a, data journey, right? So I'm sure that they have, in some way or the other, data engineers and data scientists, and they build data pipelines, and they're trying to analyze all their data to figure out, hey, what is the next business to invest in? And you can apply this to a bank, a shipping company, whatever you feel like.
Right.
And if you imagine this data pipeline, their data engineering team and their data infrastructure to be a large, you know, ship of sorts, right? Think of a
Right.
large ship. It's a complicated system, too many moving parts, engine, propeller, tanks, hull, 100 different things. Acceledator is essentially the cabin, right? The captain's deck. You
Right.
have all the information you need about this extremely complicated system at your fingertips, and you have information from different sources all tied together in a way that it allows you to make the right decision when things go wrong. That's essentially what
Got it.
Accelerator does. And we are building it, as of course data observability has a practice level associated with it, right? That it needs to be adopted by engineering teams, and then it has the, the software associated with that practice. So we are in the business of, defining that practice of what data observability is, and also to build the reference implementation of how people should do, something like data observability. So that's what we do.
I think this was amazing explanation out there. Great insight shared, and I know for a fact you've kind of covered a lot of ground in terms of monitoring about application developer, even watching out at the performance real time, which is super important. I know for a fact you also mentioned about data observability, and something when we talk about obviously data observability, the most the most heard question, or the most where, as far as I have seen people asking a lot around, is what is the difference between data observability and AI observability? What's your take on that, Ashwin?
Yeah, that's, I think they are very closely related, right? And you might, in my opinion, somehow in some way AI observability, or let's say, even if you call it, let's say, observability around AI and ML systems, right? It makes a little bit
Hmm.
more sense to think about it like this. It kind of folds in into data observability at some level, right?
Okay.
But um, the way it would be, and AI systems are essentially data systems, right? So
Hmm.
they build insight on some data which is existing, right? And to
Got
build
it.
this insight, there are two aspects. One is that what is the outcome of a AI or ML process, which is mostly models and related tech around generating models and deriving insight, right, on top of them. And there's the data aspect. So if your AI system cannot get the right data, or you built your model on a certain set of assumptions, but that data assumption has changed in terms of the data itself, then it also becomes, a data problem, right? Is that the data is not fine. So the way I think of it is not, I don't think there's like a, the difference is in what they observe, or in what they, actually look at. So in the AI observability world, a lot of companies which are out there are essentially looking at model performance and model monitoring, and what does the, what it means, and data drifts and things like that. And for us, I think in the future maybe it folds into something like a data observability platform or a software, but we are, I think, one step behind, where we look at the data and not
Got it.
necessarily the models and the technologies that which are running.
Okay, that makes a lot of sense, where you are obviously focusing more on the data as of now, and the models kind of come up later. And
Exactly,
yeah,
yeah.
that makes a lot of sense. You're also that brings me to another question which you lightly mentioned about, was about data reliability and data quality. So how do you, since you are in a stage where data kind of plays a very important role, how do you look at, how do you actually get into the data reliability and data quality? What are the key components that you look, and what's your take on this?
Yeah. Can you still hear me? Yeah, now I think you
Yeah.
can.
Yeah.
Yeah, it's a great question. So, like I said, right, I think the definitions are important. So, what ends up happening
Yeah.
is that um, data quality is, easy to understand, right? There's some data in your table, in your data store, and whether that fits a certain assertion or not, right? That's essentially what data quality is. How many nulls and what's going on. Now, for me, I think data quality folds very nicely into data observability. Why? Because data observability, according to me, is a much broader aspect. It is more of a practice, right? In which data quality can play an essential role, and the same with data reliability. And I'll explain why I say it, right? So just
Yeah.
imagine any complex system, right? And you can look at a data pipeline, and just imagine, let's say, a technology like Spark. I think we're going to talk about Spark a little bit in this context.
Yep.
Now, when you're executing something on Spark, and there is an input, there's an output, and the Spark system is in the middle, right? So you ran a Spark job, there's an output which came in from an input, and then this function, which operates on this data set, can do one of many things, right? It might be an analytical data set, might be a machine learning workload, it might be anything. But the fact is that there was some data which was fed as input, and there was some data which came out of the processing. Now,
Right.
if you look at take a holistic view, that hey, as an expert, do you understand the system? So you can't just start with something like data quality. Like, is the data which this system spat out, is it correct or not, right? Because that's just an aspect of what it does. So a complicated system like Spark, or any query engine, or any analytical system, essentially has three or four aspects related to it. Number one, it's never in isolation, right? The data which this Spark job ran actually came through some sort of a pipeline, right? So how did it arrive, right? What is the journey it took? How long did it take to come? When the data came in, how was the shape of it? When you analyzed it, then what really happened. The second is the Spark system itself, which is essentially an execution engine. It's a compute
Mm.
function which runs on infrastructure, which might be running on the cloud, right? So if how you run a Spark job is different in the way you run it on your data center. It might be different if you use a engine like EMR. It is different when you use Databricks. There are different performance characteristics. The configuration of this Spark job played a huge impact on how fast or how efficiently this data was processed. And then came out the data on which you want to know whether it is reliable or not, right? So according to Accledata, the observation scenario is all of it, and not just the quality of the data, right? So
Mm.
that's why if you look at our website, and if you look at our hypothesis, and if you look at our literature, we always talk about infrastructure and compute, we talk about data reliability, and we talk about pipeline monitoring, right? So when you put enough probes, so what we do as a company, what our software does is that we put probes not just on the data to measure data quality, but we put probes in the Spark engine. We will put a probe in your compute environment. We'll put a probe in the data pipeline, which is maybe something like an Airflow. And then when this execution happens, we have all the information which is required to ascertain why something went wrong. And if the data is of poor quality, or if you talk about a reliability scenario where you say, hey, not all of my data was processed in time, then we don't throw an alert and say, okay, you don't have, instead of 100,000 rows, you got only 10,000 rows. But we can also tell you why it happened, because we also understand infrastructure and compute, and things like cost. How much does it cost to actually do this kind of analysis? So for us, data reliability and data quality are aspects of data observability, which I think is a larger umbrella. And we as a company look at it at a very, from a holistic point of view, where we look at the end-to-end journey of a data. And that's why the whole concept of multidimensional data observability. And it's not just related to if your data is late or if it's, not coming on time and things like
No, I think this makes a lot of sense in terms of tying data reliability, data quality very well with data observability, and obviously data observability sitting out there, as an umbrella for both of these. And there are many more aspects that obviously you've spoken around that you kind of consider before even saying that the data kind of is reliable and is rich in quality. And that's one of the reasons why Accledata is one of the leaders out there because you know your game very well, Ashwin. So thanks for sharing those insights. Also, I know for a fact you spoke a little about Spark and Databricks here. So I wanted to shift gears a bit around and understand, since we know Databricks enables users to manage clusters and deploy Spark applications in cloud environments. So there is a ton of activities that are going in the type of environment. But how does data observability play a part, and what can it do to improve the cluster performance? I know you've spoken a bit about it, but why not get into the weeds of it? Yeah.
that. Yeah, it's a great question. Yeah, so Databricks is a great company and a great I think a great compute environment for people
Yep.
who don't really want to manage a lot of these things themselves, right? So the critical part, I think, is management, right? To run a cluster reliably, you need great talent, you need excellent infrastructure, which I think Databricks has. Of course, they
Exactly.
improve the Spark engine and then they make it a managed service, so you don't really have to do something. So it's a very interesting offering out there, right? Now, there are
Yep.
two aspects to it. One is the question which you mentioned, which is how do you improve something like a cluster performance?
Yep.
Yeah, this is, which I like I mentioned, this is an aspect of observability, right? What can I do to improve my performance, right?
True.
If you are on the application world and you see that your HTTP call is slow, you might say, what can I do? And then you figure out, okay, the database connections are all maxed out and I need to increase the connection size. So there is sending information saying something is wrong is not sufficient for anybody to take any action towards it, right? So what do I do next? I think that's the important question. So I'll touch on two aspects of it. So what can you
Yep.
do in terms of cluster performance? In my, when I was speaking previously, what I mentioned is, for all of the platforms that we support, we build probes which you can instrument in your environment, right? So one aspect of it is that we have two important probes that Databricks customers can use. One is that if you use our software for Databricks, which is in preview right now, we are gonna install, or you're gonna instrument your Databricks cluster. That is number one. The number two thing which you can do is we also, as a solution, we also provide an SDK, and that SDK you can actually integrate in your Spark jobs, and you can
Mm.
define, just like how a developer would do, important aspects of what the behavior should be. And we also
Got it.
do collect a lot of information around how much time did it take, how much time did a method take to execute, and things like that. And then at the end you can put a probe on your data as well, which is, maybe because you're using Databricks, it is sitting in Delta Lake, so you can pick a Delta table and you can say, I want a quality assessment on this table. So now
Mm.
imagine when a Spark job is running inside the Databricks environment, we are getting information about the EC2 instances on that. Let's say, assuming it's Databricks for AWS, we are getting information on the EC2 environments which it's running on. We are getting information about the Spark job, its performance, its configuration, its shuffle information, all of that information which you would like about Spark. You're getting
Mm.
information from our instrumentation which says, if you are doing, let's say step one, step two, step three, you can describe using our SDK that I'm actually now doing, let's say the data processing part. Then now I'm doing unification. Now I'm doing deduplication. You can actually define this aspect. right?
Okay.
And the fourth part is that now the data lands in something like a data lake, and you're also running the quality run. Now just imagine that you on the Accledata platform, you can come in and it shows you that your data ingestion started at T0. Then there is a Spark job which was executed, which had this
Mm.
configuration, which ran on Databricks, from which the part one took 5 seconds, and the part two took 10 seconds, part three took four
Wow.
seconds, which resulted in a Delta Lake table for which the quality score is 84%.
Okay.
Right. So now for an observer, right, it's essentially
Exactly.
very clear on what this data pipeline does, right? So you
True.
can look at it from a data perspective. Did my data come on time? How much time did individual processing steps take? And if they took long, can I look at the Spark configuration and make a change, right? So what we want to do is, when we want the implementer, or the data engineer, to have every single piece of information, which
Yeah.
allows you to make the right changes or the judgment on a daily basis. And that's where the analogy of the captain's decks comes in, right? You have all the information you need, and when you have all the information you need is when you can make the right decision, right?
Wow, I think, yeah, definitely. This is something which is super interesting in terms of, when you kind of have like all the statistics in place, you have like all from point A to point B to point C to point D. If you see everything, how your data is running, what's happening in there, and you can definitely understand each and every aspect of the data pipeline. I think it's a big win for those who are actually running the data there. And observability obviously plays the most the most important role there. So I does
Exactly.
this also help a lot of data engineers, and not only just them but also the business folks, to make decisions according to that okay, we are kind of I know for a fact I have a question around the costing bit as well, but does that also impact the decision making in any way? Have you like seen that, Ashwin? Do you have any example that you
Yeah,
can share?
I think it does. So for for stakeholders, what is most important is the outcome, right? Which is
True.
essentially SLA, right? um, Most problems where we face, where you have to work kind of backwards from why an SLA is not met, right? That's like the basic starting point, right? That your SLA is not met, and why that SLA is not met. Now, a lot of our competitors, or you say data observability companies, are more or less kind of concentrated on what really happened from a data perspective, right?
Hmm.
So think of a concept like, my data has not come, or my data has duplicates. It's all about what that aspect is, which then leads to you know the end result, which, so for executives, it's all about SLA. Now, how do you define in a complex scenario what part of your system is not working correctly,
True.
right? That can only be defined by going deeper inside, and a lot of instrumentation, right? Where you go and at least every aspect of the system, and only then you can actually define what is going wrong. So if you think of a CTO or a VP of data engineering perspective,
Yeah.
what is the question they're asking? Why is my SLA not met? Why is the data late? Why is the report incorrect? Right?
Exactly.
And what we want to do is answer the why question at every single level,
Hmm.
right? So for us, from a business perspective, we are an enterprise company. We talk to a lot of state stakeholders, CDS, VPs of data engineering. Their first question is all about, why is it late? And nowadays a little bit more, why is it expensive, right? So
Wow.
that's where
Yeah.
they concentrate. Yeah.
Yeah, that's very true. And talking about the second point, why is it expensive? I know for a fact, cost overruns you know are a killer for data teams, where CDOs kind of obviously focus a lot nowadays as well. And not only just the CDOs but also the exec teams, they obviously want to make sure that there are no cost overruns. So how does data observability provide a part to better cost monitoring? but when running Databricks cluster, that is something what we can, can you
Yeah.
put some light on that as well, Ashwin?
Yeah, I'll try to generalize a little bit.
Yeah.
Not specifically concentrate on database, but I think it would be kind of obvious, when you hear the story, right?
Yep.
Now, two aspects. One is that on cloud things are expensive, which everybody knows, right?
Exactly.
And now, why does it work like that? And I'll take a little bit time explaining this.
Yeah.
Um, for a business, a big business, AWS is a cost which you pay for flexibility in infrastructure, right? Cloud is a
True.
cost you pay for flexibility in infrastructure, and and basically Amazon and all the big cloud players essentially want to capture. This is huge business. Infrastructure is huge business. Now, what
True.
ends up happening in a typical scenario? You take a bank, and a bank, the internal team wants to build a internal app for which there is an audience of about, say, 2000 employees. That's all they want to
Got
build.
it.
And this is essentially an internal app which does some, I don't know, some price prediction or something, yeah, whatever it is.
Got it.
Now what will end up happening is that they will realize, if they build this on AWS, that this is going to cost them $200,000 a year. Why is it? Because when you build on AWS,
Mm.
what is the team going to do? They're going to build redundancy, multi-region, you know miscalculate the amount of resources it needs to actually build an app which serves 1,000 people, right? They'll have load balancers, and they'll have backups, and they'll have all kinds of strategies for an application which does not need, right, which could be actually built on. If you had a data center and you had limited resources, you would say, hey, you know just use one or two instances of machines to actually build this. So the the crux of the matter is that the fact that compute is cheap and easily available is
Mm.
lends itself to abuse, right, at every level. So if for every single app you have redundancy, and you have bandwidth, and you have big machines, and you have all kinds of stuff going, then every single app is going to cost $100,000. Now imagine a company which is building a data pipeline.
Mm.
Data pipelines are built largely on environments. Let's say if you choose open source environments, then you are actually building your data pipeline on the work on existing software. For example, Kafka.
True.
For example, Snowflake or Databricks or Spark, Presto, open source stuff, or even cloud stuff. Now this is one layer on top. So when you pay Snowflake for running a query, you have no you have some idea of what it's going to cost, but you don't have like a very good understanding of, when hundreds of people are using Snowflake, and then you're consistently running your queries, you don't really know how long it runs, how is the attribution, who is doing who is running more query, and then you don't know how it actually impacts from a cloud cost perspective. So your cost is not just your cloud, but your cost for something like Databricks, which runs in your own environment, is also your own cloud expenses plus Databricks expenses. So because again compute is cheap, you think you can you have infinite capacity, you might put some settings, you might put things where you can just blow off the cost, right? So again, so from a data perspective and a cost perspective, again, I think that Accledata is in a great position to understand why this happens, because we have probes everywhere, right?
Exactly.
So if you look at a query which is running, we can actually tell if it's running efficiently by looking at the performance of the, the actual performance numbers of that query, and then we can
Wow.
figure out how much it's costing. And then we have mechanisms which says, if certain queries cost more, you can actually trigger actions to kind of go ahead and kill it, or you can alert it. So for us, when it comes to FinOps, right, which is the newer term, just like data observability for cloud costs, like financial operations, FinOps on cloud. When it comes to FinOps, it's again, it's very natural for us to kind of consider this as an aspect of data observability, right? And not FinOps when it comes to, hey, is my EC2 machine costing too much? It's about the cost of a data pipeline, or a cost of a data operation, or the cost of a certain SQL, and whether it's rational or it's not rational, right? And then having enough, again, since we have probes everywhere, What we do is we collect
Mhm.
information, we attribute it to the right cost, and we present this information to our customers so that they can make the right decisions. Right. So that's how it works. So whether, do we kind of, reduce cost for data teams? I would say we present all the information so that they can
Right.
take a decision whether it's running efficiently or not, right? Because that's what we do as an observability company. But we are not
Mhm.
in the, business of saying that, why are you spending so much? Why don't you shift your engine? No, none of it. But
Yeah.
we present that we have the information and we present the information.
Yeah, I think Ashwin, definitely it makes a lot of sense when you say that. It's more on the lines where you are, presenting to companies and showing them the results with data observability, that these are the costs where, obviously when you say there's a query running, we talk about, we'll be actually looking at the performance numbers, then understanding the cost, and then presenting it to the folks who are actually, wanting to take up Accledata. So it does make a lot of sense. And yeah, FinOps is something which is now very, very much, a thing where, I know for a fact where CDOs, the SMEs, they kind of focus on that as well. So it does make a lot of sense. Also, that I know for a fact we spoke about a little about data reliability, but this kind of brings me back to, with all this happening, the reliability of the data is maybe the most important factor that I see, when a query is running, when the data is running. And how can data teams look at all their data sources and make sure, all the data being processed through your Spark jobs is reliable? Like, what's your take there, Ashwin?
Yeah. Like the way we at least kind of rationalize it, and just let
Yeah.
me read through the question again. Yeah, that's great. So yeah, so let me get into a little bit of a detail here, right? When you talk of data pipeline, and
Mm.
if you talk about a solution built for data pipelines like Axel Data, there is a notion of, in the end, what is it, right? Even if you take a data quality tool, what is it doing? It's essentially looking at a data table in your environment, and
Mm.
it's figuring out certain properties of the data, right?
True.
Now let's assume that you had a table with a billion rows, right? And one easy data quality metric, let's say, is the number of nulls, right? So
Correct.
if you had to build a data quality tool, all you have to do is you have to provide a way, a UI, in which you can essentially say, check the nulls for this column, and that will be translated into a query which will be executed on this billion row table. So we'll say, select this table where this column is null, and out of a
Correct.
billion, let's say 200 million are null. So you say 80% is perfect, 20% is bad, right? Now, for us, like I said, we build probes for every aspect of the data pipeline, right? So let's
True.
assume that you have now a delta table, or a data warehouse table, which is being produced by something like a Spark job, and you want to know it's reliable. Now, what does reliability mean? Reliability might mean 10 things to 10 different people, right? So it might be
Correct.
something about data quality for team number one. It might be about timeliness for team number two. And for some, customer, like a financial customer, it might be that the addresses which have come in as the column, the pin code should be a valid US pin code, right? That might be updated. So if you take
Correct.
a kind of a technical approach to it, and we say, hey, why don't you design this software? You would say, hey, because I have to process a lot of data, I provide some sort of a compute environment where you can send all these queries, which will go and figure out whether data is correct or not or whatever, right? The way we approached it is essentially, it's very simple, right? Unlike our competitors who are querying the data from their software, from the cloud or from on-prem, and looking at data quality, what we have done is that we said, what we are doing is that we ship a compute environment right next to where your data is. So if your data is on-prem, we will give you an environment which is managed by Accledata in your on-prem. If your data is on BigQuery, we will give you a compute environment which you can execute inside Google. If your data is on AWS Redshift, then we'll give you something which you can execute. And this is a managed service, right? So everything is managed from the Acceledator environment. Once you have that, then based on what you think is data reliability, you can send a workload to this environment. Now, this might be a data quality workload, this might be a data security workload, this might be a sensitive data detection workload, it might be a compliance workload, it might be anything which you think is data is essentially is data reliability. So we don't have a reductive approach where we reduce everything to say, hey, is the value in this column correct? That is what data reliability is. Your data reliability is different when you are a medical guy, when you are from a finance financial company, to where you are a data provider, right? And what we need to do is we need to enable the customer or the enterprise to be able to define what reliability means for them, number one, and then have it execute efficiently on a certain environment. So the key difference for us is that we can provide a mechanism to execute whatever the customer thinks reliability means for them. And it might very well mean data quality, but it might also mean, that, sensitive data is not being, shown, right?
Right.
Right. And it might be about, it might be about missing fields. It might be about, changing schemas. So all of this, which comes under the larger umbrella of data reliability, can be executed from our engine, right? So that's how at least we have designed it.
Okay, that's very much fair and great details there, Ashwin. Also, I know I've spoken a lot around data reliability, data quality, but also, can you walk me through a scenario where data engineering team can use data observability, to model scenario-driven planning for data validation and reliability together?
Yeah, this, great question. I don't know if I understand all parts of it, but I'll try best way to answer this.
No
So
worries.
how does a data engineering team use data reliability? It's a simple, pretty good, easy answer for it, right?
Mm.
I think data observability should be top of the mind when you are a data engineer. And why do I say that? Because it's not a post the fact, monitoring system that you need to look at, right? And I can easily draw parallels to the application observability world, right? So, what is a good engineer, right? Or what is a well-designed software? A well-designed software, let's say you're building a REST API or a service, is when the developer has put in enough information about their functionality that it could be observed, right? And how do developers do it? They write log statements, right? They write traces. They use something like open tracing. They write, metrics. They emit metrics. How many connections are open? How much time did this part of the code take? So a good developer, when they follow good development practices, will
Mm.
build in these things as they go along. In the same vein, what data engineers can do as the practice of data observability matures, essentially use a toolkit like Accledata, hopefully, in which they can put in the right probes in the right places. So when their job or their data pipeline actually executes, they have all the information that they need to go and basically verify, validate, correct, change, measure, monitor, right, and have the right information they need. That's
True.
essentially what a data engineering team's responsibility is. Not post the fact that I wrote a job and tell me why it's not working, right? It's also, of
Right.
course, we provide that capability, but I think from a practice perspective it only works when there are certain good practices that you follow. And my hope is that data observability also just doesn't evolve as a market for software, but also as a practice where people follow certain known design patterns, where your system, your data engine, is more easy to maintain, operate, observe, and things like that.
I think this is very important and you mentioned a very important point here, where data engineers should actually understand data observability very well because it will help them to carry out many of the aspects very smoothly when it comes to, data pipelines. So great answer there, Ashwin. Thanks for that. Also, I know we've spoken a lot around data quality, reliability, and other stuff in data. But a question that obviously is that I had in is kind of a hot topic right now about modern data stack. So what are your thoughts about that, Ashwin?
Yeah, I think you can look at it from a generational perspective, and you can have
Mm.
multiple definitions around it. But I think an easy way to conceptualize and understand is as simple as this, right? So I started my career actually in a
Yep.
company in which my first job was essentially working on a ETL pipeline on this thing called SSIS, SQL Server Integration Services. And once the integration pipeline used to run, it used to put out a report into a table. That table was actually built on DB2 for some reason, and on DB2 there was a system called Cognos. Now this system essentially used to work in a very batch mode, right? So you had like a month-end reporting, you had a weekly reporting, you pick some data, an ETL pipeline runs, and then it provides some information into a table. Then you have something like a Cognos BI where there is like a developer who's doing it, and then you get a report, right? So it's a completely kind of a back office function for any
Mm.
enterprise. And then came in the, the compute, or let's say processing became cheaper, right? Became
Mm.
more commoditized. So as you went on from that world, things like Hadoop came in, where you say, hey, you don't need a vendor to come in and give you like a big
Mm.
machine and then you run stuff on it. Here is you can run this on commodity machines. It's a distributed architecture and you can run it, right? So if you
Yep.
consider that as like the next evolution, and then frameworks like Hive and things like that. Now the essentially the what you would call a modern data stack is the next step from that, where you're saying that, hey, now at this point in time,
Mm.
cloud is the cloud systems are so pervasive, right, and so available, and in some sense also cheap, and it kind of conflates to what I said earlier. But if you take away the management, data center running, having a person actually operating the whole data center, all of that, then in some aspects that you don't pay as much for the cloud if you had to maintain your own infrastructure, right? So in terms of at least even people, right? And is at a certain price point where you can do a lot of it. And of course the nature of work also has changed. Data has become a lot more real time. You need to have there's a company, even a company like HDFC in India can run
Yep.
like a job which will tell you whether you're credit worthy in about 5 minutes or so, right? They have things like that. So as this motion to cloud has happened, a lot of this this effort which was available, which you had to do to kind of get something going, whether it was on the Hadoop stack or whether on the the one before, has kind of gone away, right? So a lot of the motion towards what is a modern data stack is also very tightly coupled to what is available on the cloud, right? So when you
Mm.
talk about then warehouses, then a modern data stack is essentially saying, hey, it's a cloud warehouse. Either it's Snowflake or it's Databricks, or it's maybe something new like Starburst, right? And
Yep.
then of course, now that you've moved your compute and your data on the cloud, of course the
Mm.
rest of the stuff also need to kind of move, right? So whether it's governance tools or ETL tools or reverse ETL tools or ELT tools, right?
Mm.
They essentially have moved from what used to be an Informatica slash SSIS kind of domain into something more open source and more conducive to this environment, something like DBT, right, where you do a load and you do a transformation. So, in my opinion, the challenges don't really change, right? You earlier had a challenge on prem, now you had a challenge you have on the cloud. Maybe the aspects change a little bit, right? You're not so worried about saving compute cost, because on
Mm.
prem, if you had to get more machines, you have to buy servers. That's not
True.
like a huge thing. You're not necessarily optimizing on the same environment, the same aspects, but the
Mm.
challenges are same, right? Even on the modern data stack, you have to do data governance, you have to do master data management, you have to do
True.
data quality, you have to do data observability. All these challenges don't change, but I think a lot of this modern data stack is tied to being available on the cloud. right? And if you look at the reference architectures which people send, it's a lot about what's on the cloud. But for us as a company, challenges are the same, right? Everybody, you still had a problem on Hadoop, you still
Very
have a
true.
problem on Snowflake. The nature of the problem is slightly different, and the solution
Hmm.
is still that you need to place probes in the right places so that you can get the right information. Just the placement has changed.
Right. No, I think this is amazing, Ashwin. A great explanation about modern data stack. It's more, obviously it's more about the business problem solving, and I think for Excel data, it's more about putting the probes in the right places, and that's what you do the best. And it kind of brings in a lot for you and your clients as well. So, great stuff there. Also, I know we are towards the end of the show, but would love to hear your thoughts. I know it's the space is kind of evolving very fast. Even the data observability space back then in 2018, it was completely different, if I would say, and now it has changed a lot, and there are more uh, people have learned a lot more now about this space. But where do you see data observability space in the next 2 to 3 years, Ashwin?
Um, so I think the tech industry is such that there's a lot of noise which comes in when there's something new,
True.
right? And you can see it, everywhere, right? Take Web3 for example. A lot of people have tried to define it. Then there'll be people who will be like, oh no, that definition is not correct. This definition is correct, and this stuff goes on and on for years.
Right.
But what doesn't change is that any business and especially any software, I think the way to look at a business is, does it bring value, right?
Mm.
And I think the data observability as a business, as a space, will survive as long as the companies which are building it actually build value, right?
Mm.
Now, we have chosen we have a certain way of looking at this problem, which we think brings the most value, right? So, for data observability, where do you see the market going? I think number one is that adoption. A lot of these are
Yeah.
also practices, not just software, but it's also practice that you have to use. Just like you have as almost given, like you have some sort of monitoring tool when you write code. The same
Right.
way, I think you have to have data observability needs to become a practice. Number one, and number two, I think the responsibilities for companies like us is to define what the value is, because you can define a space in 100 different ways. You can say, oh, this is umbrella of data quality and compute, but do you bring value? And I think for us, a good sign of where this market is going is the kind of customers that we are able to work with, right? So some of our customers, if you look at our website, is true blue chip of the blue chip companies who have kind of expected interest in working with us. So if you take Visa, Dun and Bradstreet, um,
Yep.
DBS Bank and Phone Pay and Pratt and Whitney. So the way I look at it, right, when companies like this are willing to work with like a 3-year-old startup which is in a kind of a niche space of data observability, then it tells me that there is we are in the right direction. But like a
True.
space is usually defined by a cohort, right? So it all depends on eventually what brings the most value will be what how data observability is defined, right? What is it that brings the most value? And if that, like you said, you were talking about data reliability being key. If that is the key, then a lot of data reliability players, sorry, data observability players are going to concentrate on reliability as an aspect, and the rest of it might not take a lot of uptake, right? So that's how you basically kind of construct a market which is kind of defined by the value which you bring.
A fantastic take there on the data observability space and the future of it, Ashwin. This is amazing. Also, a quick question that I had was around: does Excel data also have resources to learn about data observability in this space? Do you have like books or blogs that you kind of put
Yeah,
together
so
where we
I,
can?
I
Yeah.
I think our LinkedIn is a great place. So if you follow us on LinkedIn, which almost every professional is on LinkedIn these days, if you
Yeah.
follow us on LinkedIn, you can get a lot of well curated information about about the space, about the tools, about practices, and what we do. Another good place is if you go to our website, there's a resources section where we have put in a lot of case studies and blogs and articles of what we want to do. We're also kind of somehow the whole COVID situation has meant that a lot of our team was not co-located, right? So we hired like a lot of people all over the place, and now we have kind of come together and we're starting to work from office, right? So we are now planning meetups and get-togethers. There's one happening I think on the 29th, which is about Snowflake at our Bangalore office. Details are on LinkedIn, and you're most welcome to come and meet us as well. And of course, kind of a pitch there. If you want to learn more about data observability, and if you think you want to work in this field, we are hiring for all positions. And
Wow.
so you can reach out to me directly, and we solve some, especially in the Indian startup landscape, right? There are very few what you would call, or what investors would call, a deep tech company. So we happen to be a deep tech company, and so
Right.
if you want to do deep tech, you guys are most welcome.
No, I'm sure there are many folks who might be super interested to learn more about, like you said, deep tech, and would want to work with a company like Accledata, which has fantastic future, obviously, with leaders like you, Tristan, Rohit, out there, and the complete team, I would say, are doing fantastic. But great information here, Ashwin. One last question for anyone who wishes to reach out to you for any of the information around data observability, even for if they are looking out to work in this space, which is the best place to reach out?
Yeah, so just write to me. I'm not too much on social media. Like I said earlier, I'm a kind of software architect at heart.
Yeah,
So, Ashwin at Accledata.io is my email. You can, write to our company's careers page. You can also find me on LinkedIn and drop me a message. And, like I said, just let us know from any channel, and, come and meet us in office. It's great.
amazing. This was fantastic, Ashwin. Thanks for all the information. We spoke a lot around data observability, data quality, data reliability. Thanks for providing each and every detail, out there. You've made us more, at least I've learned a lot more about this space, and curious to see how, this kind of evolve in the future. But thanks again for visiting the Ravit show, and see you soon for maybe a 2.0 session. And I'm definitely looking forward to the meetup that's happening on the 29th. I'll keep you posted. Maybe if I get a chance, I'll be happy to visit Bangalore. Yeah.
Great. Yeah, most welcome. Thanks for having me on the show, and I think you're doing a great job. Like I said, I'm good to talk. Just about on any topic that you're interested in, right? So, thank you again. Have a good day.
Thank you.